So here's my 2022 bracket, one of many, but maybe the simplest one. Having Gonzaga winning over Kansas, two #1 seeds, which probably is not going to happen. So it's kind of a boring bracket, but maybe the most likely of a bunch of random madness that can occur. I have Kentucky and Tennessee, 2 and 3 seeds, also in the Final Four. And that bracket was developed on this spreadsheet here, where you got 64 teams listed on that column B with their rating, which I've gotten from 538.com in recent years, and then the indicators of who's going to win. So you can see Gonzaga is winning 6 games to claim the championship, and Kansas is winning just 5. So they're in the championship game. And you can see the other Final Four teams here. Kentucky and Tennessee both win 4 games. Apparently Kentucky beats out UCLA, and those two teams, I kind of have half my brackets have UCLA winning, half have Kentucky winning. The other mix is down here with Tennessee and Kansas. Those two alternate a lot, as well as I think I've got Auburn winning a couple. I got like 5 brackets, and so those are all pretty good teams. So it's pretty obvious that those are potentially good teams to claim. Here's the top 16 according to that data from 538.com. I have Gonzaga winning in all my brackets just because they are so dominant as they were in 2021, which they fell short in the championship game to Baylor. But maybe this is their year. So they're much more probable chance of winning it all than these other teams. A lot of teams with like a 3% chance. So any of those are all good Final Four potential teams. So that data is coming from 538.com. So here I put it into the spreadsheet. If you find it on the web, just do 538 March Madness, and originally from the 538 members of the House of Representatives and the Senate, including DC, that vote on the election every 4 years. So that was the originator of this. The guy who started with trying to predict elections back in 2008, maybe, or maybe it was 2012, from that era. So you can see Gonzaga's got a pretty good chance, and Kentucky's got an 8% chance on this. I pulled that data off of the table sheet over here. And so you can see it. I think it's ranked. So Gonzaga's #1, Kansas #2, Kentucky's #3. And that's what you can see in my little table that I made here, where I'm using the icons from ESPN.com to fill that column for the bar chart here. So that's a cool feature that most people don't realize. You can actually put a picture of yourself or whatever picture you want here. So you can right click on that one bar and have this bar colored differently. And so you can format that data point with a fill, and you can fill it with colors, of course, as normal. You can also fill with a picture. I'm just finding a picture from a file on your computer. So I've been doing that for years. It's a little cumbersome because you got to fill out 16 bars here. So you got to click on those, and it maybe takes 5 or 10 minutes to do that. So it's kind of a cool picture. But if all these numbers, if the data changes or something like that, all the pictures are in the wrong spot. So Arizona could be over here next year, or maybe even not in here. So it's kind of annoying to build this little bar chart, but it's kind of cool looking. So I've taken that 538 data, 538.com data, and you can see over here the conversion of that to useful numbers, because he's got little check marks and less than 1% signs. So I'm basically cleaning that up a little bit over here. So here's really that data. And I've organized it in this, since his is sorted by the strongest team, or maybe it's sorted by regions, but sometimes sorted differently than I want. So here you can see 2 instead of the 1 first. I want 1 versus 16. So this probability page basically just takes that data and lines it up as the bracket should be. So I've got a 1 versus 16, I got an 8 versus 9, and so forth. The ratings over here aren't really used. Those probabilities are really what's used. And so those probabilities are here, but it's kind of useful to see, hey, Gonzaga is like an A+ student here, 96.5. And, maybe Kansas was the second strongest team. Yeah, their rating is a 91.7, so like an A-. Arizona is a 91.4. So those are all the good teams, but it's pretty hard to be in the 90s. Here's Purdue at an 89.4. They're a 3rd seed, but they're not too far away from the 1 line in terms of the strength. And even Kentucky's right up there with the ones in terms of this rating. The rating is his way of doing a computer to rank the teams, just like they used to use in college football pools. The idea is that, Gonzaga would score 96.5 points and Georgia State would only score 73.5. So Gonzaga should win by 23-point spread there. And there's some probability that Gonzaga could have a poor game and Georgia State could have a really good game. So there's a small probability, 1% maybe, that Georgia State would win that. So lots of different ways to come up with that data. So garbage in, garbage out. This may be garbage, but those are the numbers I've been using for the last few years, taking these probabilities and then trying to use those to help make picks. So these are the probabilities, the top 16 charts based on their ranking. I've got a ranking here that ranks those and puts them in order down below. Here's the top 16. And Jeff Sagarin ratings. Those I don't have anymore. That's what I used to use in the very first computers from 1984. So that's the data. As the tournament is played, I can fill in the results. So if Gonzaga wins that first game, I put a 1 there to say, yes, they won. 0 indicates you lose. Of course, you can't have 2 teams win in the same game, so that's impossible. And you have to have someone win. So I'm assuming it's going to be Gonzaga. When Boise State and Memphis play, I'll fill in those manually as well. You just went by the seeds, you'd say pick the 8 always over the 9. So this is kind of boring. This is just the seeding committee. I always try to see how well I do versus the seeding committee. So you can kind of grade how well they do with the results. So if you do a sum product of the results with the seeds picks, you do a sum product of those 2 big rectangles, it will count up all the times there's a 1 in both spots where they got the right pick. If they pick Boise State and the results say no, Boise State didn't win, instead Memphis won, then a sum product of that cell times the pick, which is a 1, gives you a 0 times 1, there's a 0. So it doesn't count. You lost that pick. And then same thing here. Memphis actually won, but you didn't pick them to win. So 1 times 0 gives you no benefit. So the only time you're going to get a point scored is if you have a 1 in both spots where you got the right pick. So you can do a sum product to calculate how well the seeding committee does and basically how many total games they win. That's kind of boring, but that's what I used to always do back in the 80s when brackets were in the newspaper and there was no web, there was no internet, there's no brackets online, there was no online. So you could just count up how many wins you get correct and compare that to the seeding committee, and I always try to beat them. And then when the brackets online stuff came in the 90s, they created point systems. So CBS is one that's done it for many years from the beginning. Of course, they televised the tournament for many years, 30 years. So their point system is that you get 1 point for the first round picks and 2 for the second round, 4, 8, 16, 32. I think ESPN does 1. I should have looked. I think it does. Oh my gosh. 1. I guess I could look here. So here's the picks and where are the rules. Here's the rules, or maybe it's under how to play. Yeah, so they scale it up by a factor of 10, which is stupid, but 1, 2, 4, 8, 16, and 32. 1, 2, 4, 8. Oh, it's exactly the same. So it's just scaled. So yeah, you get exponential more points the longer that tournament goes. So the final picks are worth a lot more. So if you do a sum product of these points times your picks times the results, again, the results and the picks have to match. You get a 1 in both spots, you made the correct pick, and then you can multiply by the third box here by the points involved. So if I picked Memphis correctly in that first round we were talking about, and Memphis actually wins, so I got a 1 in both spots, I multiply by this corresponding box in the same position. So I'm multiplying 3 big rectangles together, the picks times the points times the results, and I'd get a point for that correct pick. And if I correctly pick Gonzaga in the final to win it all, I get 32 points. But if my pick says a 1 there, but if the results have a 0 there, that 32 points goes away and I don't get that final 32 points. You can see the traditional bracket I've displayed. This system over here I've displayed into the normal looking bracket over there. So really this video was to discuss how do you actually solve this thing? How do you get the picks to be generated? So again, I have some binary decision variables here. You have to have in each game exactly one winner. So one winner there, one winner there, one winner there, one winner there. Those are all summed up over here. So here's that first game between Gonzaga and their opponent, and a game right below it. So I have 32 games in the first round. So all those have to have exactly one winner. So my bracket is correct there. In the second round, I need just 16 winners. So here you can see that I'm summing the first 4 now, cells E3 through E6. So I'm making sure that there's exactly one winner that comes out of that first 4 pod between these 4 teams that are all in the same pod, I think they call those. So you need exactly one winner per pod. And then same thing for round 3, I need exactly one winner out of those 8, exactly one winner out of those 8. So those 8 groups of 8 need to be all have exactly one winner. And then to make it to the final 4, I need exactly 4 winners to make the final 4, 2 for the championship game and 1 champion. So these zeros really aren't needed. So I have constraints to make sure all those are 1s. I got all those 1 constraints. The other kind of simple logical constraint is you can't have Georgia State lose in the first round, but then win in the second round. So you can't have a 0 followed by a 1. You can have a 0 followed by a 0, or you can have a 1 followed by a 0, or 1 followed by a 1. Only one you don't want to allow is a 0 followed by a 1. So I don't want the first column to ever be, I don't want a 0, 1. So I don't want the second column to be bigger than the first. So I always want the first column to be greater than or equal to the second column. So you do that column by column. So first round has to be greater than or equal to the second round. So here it's strictly greater, here it's equal, here it's equal. I can't have a 0, 1, which would violate that constraint. So I got column 1 compared to column 2 compared to column 3, 3 to 4, 4 to 5, and 5 to 6. So you got column-wise constraints and then these single winner constraints. So that's basically the rules of a single elimination tournament here. What that will result in, if you solve that problem, is it's probably going to basically pick all the good seeds. It's not going to be too far away from the myopic or seeding committee results. It's kind of boring. To make it interesting, you got to fill in some constraints. You could maybe say, hey, I want Duke to win it all. So put a constraint that says this cell has to be a 1. Well, if this guy is a 1, you can't have a 0 before it because of that column by column constraint. So if you force Duke to win it all, it's going to force these to be all 1s, and it will make everything else work. And Gonzaga obviously will have to lose to them at some point. So you can add constraints. Something I'm doing new this year is I have a constraint to make it not deviate too far from past 36 tournaments, which starting in 1985 is when they had these 64 teams. So they expanded from 32 to 64. So this 1 here is I'm basically want to have 1 unit difference in all these deviations down below, deviating from my actual number of winners in each of those for each seed. So I want 4 1 seeds to win the first round. I want 4 in the second round. And this is what actually my picks have said. I don't necessarily want that, but I have 3 number 1 seeds winning in the Elite 8, and 2 making it to the Final 4. So 3 making it to the Elite 8, 2 making it to the Final 4, 2 into the championship game, and 1 winner. That's what my current bracket has. So I have 2 number 1 seeds, Kansas and Gonzaga. Those are the 2 that are playing for the championship, and of course only 1 can win. What has gone in the past, if you look at the past 36 years and my results, these are just the current results, but there's also the historical results. So this is the current year. It's going to tabulate those once I have this tournament start. But here's the 36 years prior. We had 143 1 seeds win the first round, and only 1, Virginia in 2018, I think, lose in that first round. So of those 144 1 seeds over 36 years, it's 144 teams. Only 1 is lost in the first round. 143 have moved on, and 123 have moved on to the Sweet 16. So not all of them make it the Sweet 16, but a pretty good chunk of them. You can see that 23 have won it all over those 36 years. So number 1 seed's a pretty good pick, like Gonzaga. But you have had, I guess, 5 number 2 seeds win it all, 4 number 3 seeds, and you can see the rest. And in terms of making the Final 4, about 59 1 seeds have made the Final 4. 30 2 seeds have. 17 3 seeds and number 4 seeds. So, you know, the first 4 lines are pretty much strongest, but you have some outliers here. That's always possible. So anyway, my model that I'm trying to move this year is to compare what my picks have done, saying how many they've done compared to the results. So comparing the results, so I'm comparing it to the per year. So I'm using these numbers if I divide by the 36 years. So this is about, this is like the average. So on average, 63.89% of the number 1 seeds win it all. And in my picks this year, I have 100%, or sorry, you know, 63.8 team, number 1 seeds win it all. I have 1. So that's a little bit of a flaw or deviation of 0.36. So I'm basically trying to minimize all these guys, constrain them all to be less than or equal to 1. So kind of trying to squeeze them down so there's not much difference between my picks and the historical. What that does is basically just creates, it tries to mimic some of the randomness or the madness that's occurred in the past. And it creates kind of interesting brackets, and you can change this 1 to anything you like. I tried like 0.9, 0.8. So I'm trying to squeeze these down to 0. At some point, you're not going to be able to go much further. I think the smallest I could make it was like 0.63 or something. But it comes up with a way of just coming up with different brackets. And you could, of course, if you had a more interesting bracket with more interesting point systems, that actually lends itself to coming up with crazy picks. You don't have to kind of finagle it with this kind of constraint thing that I was talking about. If you have a natural seed points or something like that, where, you know, Georgia State gets a 16 and Gonzaga only 1, you might pick the Georgia State just because you get 16 times as many points. So it makes it more interesting. But without those, with a boring point system like ESPN and CBS, they have this exponential growth. It sounds like it's interesting because it's exponential growth, but it basically just says pick the strongest teams. So strongest teams aren't necessarily the highest seeded. The seeding committee always does pretty well, but these ratings, sometimes you can see that the seeding committee has according to someone else's ratings, has made a mistake and put a team in the 3 line, and they really probably should be a 2 or something like that. So maybe St. Mary's is a 5. They look like a pretty strong 84.3, although I think North Carolina is similar as an 8 seed. North Carolina is an 84. So an 8 seed and a 5 seed basically have the same strength according to these ratings. The seeding committee doesn't think so. They think UNC is not as good as St. Mary's. So garbage in, garbage out, or that's where you need your expertise, your knowledge. Using these numbers, here are the picks, right? So to run this, you have to run the solver, but the standard solver doesn't work. This model is too big. It has 6 columns and 64 teams, so 384 decision variables, and the standard solver can only handle 100, I believe. So if you use this open solver, you go to opensolver.org, and here's opensolver.org. You can download this version of OpenSolver, and that puts it onto your computer. And then to put it into Excel, go to your File, Options, Add-ins, Go. Normally you just check the box for solver and it knows where that location is. OpenSolver, it's not going to probably even appear on this list. You can go browse for it. So you browse for OpenSolver. I think I just installed mine. I just did a new version today, and here it is. I put it into my documents folder. So if you go into OpenSolver, click on this OpenSolver add-in. So it's a Microsoft add-in. Just click on it, and it will put it in this list, and then it will put the OpenSolver right next to the standard solver that's here on the data ribbon in Excel. The model is, and you can build the model with the standard solver if you're more comfortable with that, but you just can't solve it. The same model is over here. You see I'm trying to maximize the expected points, which is again the picks times the points times the instead of the results, I'm multiplied by a big rectangle of probabilities, right? So before I start, I don't know who's going to win, but I can get an expected value. I'm using these probabilities. I'm using this probability box here rather than the results. The results I'll grade at the end or as I go, but beforehand I have to try to maximize my expected value. So that's the objective function. Got these binary decisions, which I've put into cells D3 through I66. And then these are all those constraints I was talking about. So you have column by column constraints. That's the these big long ones. So those are the column by column. And then you have those ones where you have to have exactly one winner. And then the constraints I have to kind of squeeze to keep it close to historical values. I have this constraint here and constraint here. I'm basically taking those deviations and making them less than the yellow box, and then also greater than the negative of the yellow box, because some of those guys are negative. So I'm trying to squeeze them all towards 0 by keeping them between plus or minus the yellow box value, which in this case is a 1. You could change that to something else and rerun it. So I guess I'll demonstrate that. Change this to 0.9. So now I'm going to try to make sure that there's nothing in this list that's bigger than 0.9. And here's a 1. I picked 2 number 1 seeds to make the championship game. And now by constraining it to be less than 0.9, that can't happen anymore. Because historically, if you look at the history, we have on average just 1 number 1 seed make it into the final championship game. So 36 1 seeds have made the championship game. Not to say that there's not been a year where there's 2 number 1s in there. In fact, one time the Final Four was all number 1s, one time, rare. But and maybe another year there was none in the championship game. But on average, there's 1. And if I pick 2, that's too far away from the 1 average. I'm saying you have to be within 0.9. So it's going to not allow that. So it's not going to allow us to pick Gonzaga and Kansas. It's probably going to pick Gonzaga and somebody else. So let's run it and see. So click on the solve. I resolved it, and now I have Auburn making in the championship game, and I have Kansas losing, not even making the Final Four, which is kind of strange, but I have Arizona in the Final Four instead. And this was a 1. Change it back. I probably should have saved that on a different sheet here. Arizona didn't make the Final Four, so drastically, just by changing this a little bit, creates a totally different group of Final Four, all 2 good brackets, but different enough that maybe you can, if you have to make up several brackets and you want some differences between them, here's a kind of easy way to kind of just change this guy and come up with an alternate suite of brackets. So that's the solver that you can use that will actually run this, and it doesn't take too much time, even though it's much bigger than the basic solver can handle. So good luck. Can't tear up these brackets. You don't want to throw your computer, but you can blame the computer when you want to tear up your brackets. You just blame your computer for giving you bad brackets. Anyway.